And I now call upon David Rumsey to introduce our speaker today.
Thank you, Salim. It's wonderful for me to see Peter here in the in the Map Center. We've worked together for over 10 years. Most of that time we're Skyping at 8 a.m. in the morning, California time, and 5 p.m. Switzerland time. I worked with him initially on MapTiler, which was something he started before he even began what became his company called Klokan Technologies. And what has always I've appreciated so much about Peter is that he brings a real love of historical cartography along with an amazing ability to create software that helps further what we want to do with putting historical maps online. In particular, Peter and I launched Old Maps Online, I think in 2012, at the New York Public Library in New York. And this is a consortium of my own collection, British Library, National Library of Scotland, the Moravian Library, and now the US GS, and it's over 100,000 maps. So it's approaching 500,000 maps, and it's just a major, sort of our Europeana or DPLA of historic maps. So Peter's gone on to build Georeferencer, which is something that I use on my site, MapRank Search. He's been a big supporter of IIIF, which is a very important initiative here at Stanford. And so I'm thrilled that he's here today to talk to us about what's new and what's coming. And so please welcome Peter, also known as Petr Pridal.
Thank you, David. I'm very pleased to stay here. It's for the first time for me, in fact, in the Bay Area, and it has been a ride, David, for almost 10 years. It started when I was a student at the university, and showing prototypes to different people while traveling on conferences, and it ended up quite far away, so I'm quite keen to share a bit of the story. In fact, this is the team. So if you speak about Klokan Technologies, it's those people. It's after one of our coding sprint. Does it run? Yeah. After one of our coding sprint in the Swiss Alps. So we are quite a small group of developers working on exciting GIS technologies, and most of us are really coders, so programmers, writing code in different languages. Many people ask why Klokan Technology, why is there the kangaroo, in fact? Because we have nothing to do with Australia. It's in fact, the word Klokan means kangaroo in Czech, which is my mother tongue. I'm from Czech Republic originally, but the company and I now live in Switzerland. So the Klokan means the kangaroo, and it's a nickname from Boy Scouts when I was 7-year-old. We say that somebody jump over somebody else if he doesn't respect the authority of that person, and I was not respecting authority of the leaders at that time, and therefore I received the nickname Klokan, kangaroo, and it then ended up in the name of the company. So that's the story behind the name and the logo. Who are we? We are specialized on MapTiles. You probably know the concept of MapTiles. So it goes back to first version of Google Maps. Whenever you pan and move around on a map, you are looking at small images which has exact geographical location. And those are MapTiles. It used to be images. Now it's moving to a different direction. But in the beginning, it was definitely images, and it's still the concept of pyramid behind a map, which is used in all interactive maps and all zooming interfaces which we have in a web browser nowadays. And that's in fact the main product, and the main software we really work on is called MapTiler, and it's doing one thing. turning images and raster data into tiles. Sounds pretty pretty basic, pretty easy, but we really work on this for 12 years, and it has a lot of applications. Surprisingly, a lot of applications. If you produce the tiles, you can just put them somewhere on the hosting and have a zoomable map. That's the basic idea. But people use it on a really different maps. This is an example of campus map. Basically turned image into an overlay. The MapTiler runs through a step-by-step guide when if an image doesn't have geographical location, you can in fact assign it through the software. It's a desktop software which runs on Mac and Windows, and there is really a lot of different applications. In fact, we have 200 installations a day. So people are downloading the software from all over the world, putting it on a Mac or Windows mostly, and processing it. There is this another example: coverage maps of mobile operators, cell phone coverage, where is 3G and 2G signals. This is all maps done with MapTiler, in fact. So even though the idea is pretty basic, if you work really hard on the software and making it perfect, because it do the coordinate transformations, it produces tiles in extremely fast speed compared to all other open source and other tools. It can scale as well, so you can use multiple computers to process large areas. So you can, for example, launch a MapTiler on a cluster to turn satellite imagery into a zoomable map like Google Satellite for the whole America down to 1 meter per pixel resolution, for example. Another application is with drones, where a lot of people are flying now and taking photos. And there are visualizations of various analyses used. So basically, if you produce a raster data, a GIS output from any software, you can use MapTiler to tune it into a map overlay, which runs with Google Maps and other viewers and desktop software, and it supports the OGCW-MTS standard. This is in fact showing the best places where to put on a roof where is most of the sun over the year. So what is the best place to produce electricity from the sun? One of the exciting applications, so you may already know, use data from MapTiler and not know about that. It's in fact NOAA. When they fly after hurricanes in US, they have a MapTiler installation on the board of the airplane. So just after the hurricane passed and they can fly, they are taking photos and recording the image on the ground. And while they are taking the photos, it's already transferred to a computer on the board and processed with the MapTiler. When they land, they put it on a cloud, like Amazon S3 or Azure from Microsoft. And then they share basically the link to these maps with the press, and the cloud itself, it's a basic storage of static files, so there is no server software really. In the moment when people are accessing the map, the cloud can handle up to hundreds of thousands visitors simultaneously. So it's the most like stable and scalable way how to deploy maps. Another really exciting application is really we have a client who has satellites, and they are sending stream of images every day down to the ground centers, and we are turning them into zoomable satellite map. So that's a software which really started with David, and it started for old maps, you know, and it's just different applications of the raster processing. The data mostly ends in data center like these, like the Google one, and the final result is really a beautiful cloudless map, which you can zoom and pan from your mobile phone or from your living room or wherever you are. With a comfort, but what is happening behind is really all the transfer of data, the processing, and then you end up with a nice website. In fact, one of these applications is OpenMapTiles Satellite, a project we finished 3 months ago, and that's open data-based satellite layer, which you can download. So we have processed 270 terabytes of imagery to turn it into cloudless layer, and reprocessed all of this, and you can simply download and put on a USB stick or wherever you want on your notebook a satellite map of the whole world and do any processing you want. It looks like this. So this is not Google. This is something what you can put on your computer and have it offline. And we are now bringing in seamlessly also aerial photos. So in this moment it just switched to aerial photo. We can color tone. This is also exciting for the old maps, in fact, application of the color toning, because if you have different, like on the old maps, you have a map series and sheets which are after scanning with different color, because some of them were on the top of a pile for years, for example, and they are just affected by the light. So the same color toning which we apply on aerial photo is then applicable on old maps for stitching the maps together, the way that you don't see different individual scanned sheets. In fact, this is another, like, this is not Google Earth. It's again like elevation data from us, the satellite image from us, open source software, open data. So everything what you can like put on a box and bring it to the jungle or wherever you want without internet and use it as you want for whatever you want to do. So that's the background. That's what we do as a team for modern applications, for GIS applications. But it all really started with GIS. If I return to the tiles, there is in recent years quite a switch from the rasters, because it used to be always images. We always used to bake a single style into a JPEG or PNG, which looks like this one. And now what is happening in the last couple of years, it started with the mobile phones, but now it's in the web browser as well. We have vector tiles. So instead of an image, those are really shapes baked into a tile, encoded as PBF, so in a binary form, but documented and properly described. And then you have all the information inside of a tile, and you send the tile to the client, a web browser or a mobile phone, mobile app, and it's doing the styling on the client side. That's another project, an open source project where everything is on GitHub, which we work on. It's in fact launched in January this year, and it helps you to deploy and host, self-host WorldMap. So what we do is basically we take OpenStreetMap data and other open data sources and process them with our software and create a 55 gigabyte file which contains the whole world as vectors. So you have every single house, every single street which is in OpenStreetMap, all the names, all the points of interest, shops, everything squeezed into 55 gigabytes. So it can practically fit on a USB disk like this. And you have your own like alternative to Google Maps, which you can in fact style the way you want. And you can, we have 55 languages inside of the vector tiles. And all these data, if they go into a client, then you can interact with the data, which is also very exciting. So this is a style done with the data. You are now looking at 55 gigabytes of data just streamed as individual tiles. All open source, all open data, all on GitHub. You can play with that and do what you want.
In vector?
This in vector.
Oh.
Yeah. So that's vector tiles in a web browser. There are also open source SDKs like from MapBox, MapZen, and others. So you can in fact load these tiles. You can make an extract. The whole USA has about 3 gigabytes. So quite easily, in fact, packable in an app, and there are already dozens of applications for offline displaying of these data in mobile apps. As I said, all on GitHub, OpenMapTiles. Together with the data processing and software, we provide also open styles. So those are the examples of how you can in fact define on top of the vector tiles, on top of the data, the look and feel of the maps. All of them CC BY or BSD licensed, so you can start with this, modify the colors, adjust it the way you want, and use it as you want. The vector tiles contain also information about the height of the building. In fact, the JavaScript viewers and other SDKs can draw a basic 3D with extruded shapes of the buildings. And what is also really cool, you can combine all of this with your own data. So if you are producing, it can start with a basic like GeoJSON. You are vectorizing an old map of excavation for archaeology, for example. Just basic shape in GeoJSON can be combined with this and visualized the same way. You simply assign, if you have information in the GIS data about the height, you can do the extrusion and make nice blocks for showing the site. In fact, one of the projects using this technology has been presented 2 days ago on a Pelagios conference, completely open source application where we turned amazing data from the researchers into a vector map. So what you see here is a zoomable map about 300 after Christ, Roman Empire down to individual streets, and you can in fact, because it's all vector data, you have the power to rotate and draw it the way you want. But the researchers put into these, it's over 28,000 features collected with link data, recorded. There are also names in Greek, so the language can be switched, and you have also different time periods. So this is, I believe, a beginning of something really big, where we will have a map with timeline, and you can just drag the time back, and it will basically change the place names, change the roads, and switch into time which you are looking at. Because of the vector data, it's in fact pretty easy to change the look and feel. So the whole map you have seen is hosted on GitHub. There is no server, so really, it's just process data, put on GH pages on GitHub. So it's a static website. You can put it everywhere, and it's fast enough. It also doesn't need any. It's not a proprietary software. No proprietary software is used on the whole process, and it's powered by GeoJSON. So people can basically on GitHub open an editor, and if they see a problem, change it directly on place. It will recalculate, process the map again, and it's a great way how to cooperate on a map like this. In fact, this is the application of another style I did one of the mornings. So it's the same data, same vector tiles, just the styling is different. Different font, different colors. Voila, we have a completely different look for the map, which can fit to a different project. So the sharing of these vector data sources is I believe, quite powerful. Another really cool advantage of vector tiles is that you can combine multiple sources. So you may have a project which works on a certain area, and it's a group of people who, I don't know, who are mapping Rome, for example, or who are mapping Pompeii. And they can have their own map, and there can be a shared collaborative map on the upper scales. And the software allows you to combine these two different data sources into one map. So you may set it up the way that when people are zooming, the data comes from different sources. So it can really be done very collaboratively, that there are different groups of researchers working on different places, and if you have an agreed standard for how you encode the data, you can really work on a zoomable map with timeline across different institutions and across different groups of people, which is, I believe, pretty powerful as well. The nice thing is vector tiles are vector data, and we work together with Swiss University and students there on writing also crosswalks into GIS. So once the vector tiles are out there, even hosted on GitHub, you can basically load this as individual layers in a GIS system and style it the way you want, and of course print out vector PDFs in high resolution and do a lot of other stuff. The vector displaying technology also opens really cool possibilities for storytelling and context of the map. So you may have basically an article, and as you scroll, it gives you geographical context with zooming and panning to the right place. And this is just a few lines of JavaScript code, in fact. So it's pretty easy to do. So let's stop with the like cool new stuff. And I believe we are all here because we love old maps and the beauty of these documents. How many of you are researchers, in fact? Or how many of you are, yeah? How many of you are librarians, catalogers, or in the library world? Mm-hmm. Software development? Coding, I mean, even not yeah. Mm-hmm. Okay. And historians or expert, yeah. Perfect. So that's an example of how in the historical GIS and in this field, and the people around David, in fact, all these professions are really combined, and I love it. I love when the old documents are getting new life, and they are put on the shiny devices and revived and made available to a large number of people in a new form. In fact, if I go back to the time when I was at the university, the thesis and the main problem I've reached, I was working for a library. I'm a computer science person originally. I have a PhD in cartography, and I was working in a library during my studying, and they had a project for either playing with musical sheets, or maps. And I have selected the maps, and the biggest problem for the maps was surprisingly that they are not discoverable with a full text search. Not basically, because people come to the library and they say, well, I would like to have a map of Rome from 19th century, from maybe range of 20 years, this type of a map. And either the librarian basically knows that there is such a map and he knows what to search for, or it takes quite a long time because you have to go through different documents. Basically, the metadata description for the maps doesn't contain all the places which are depicted on the map. That's the main problem. And a basic solution is record geographical coordinates, because then you are recording what area is covered by the documents. And this goes back now I think 15 years or something like that, when I started to work on this area and prepared a tool which has been used over the last 10 years by librarians all over the world from the map libraries to create cataloging records for paper maps. So if you have a paper map in front of you and you are cataloging, this tool gives you in one of many metadata formattings the draggable bounds. Basically, you have a paper map in front of you, you search for a place name or administrative unit, it gives you bounds and you can drag it the way you want. And this is a visual way how you create metadata, which end up here, and you copy and paste it into your cataloging system. Pretty easy tool. Surprisingly, over the 10 years used by almost 1 million of people. And if you have a look at the graph, it's like weekend nobody, Monday up, Friday down. So it's really all over the world, used by librarians, and it was used for cataloging and enriching of the metadata in different catalogs, and that's very powerful. I was amazed when I traveled, working back at the library on the conferences and presented one of the prototypes in Switzerland, that those catalogers, they were recording the coordinates since 1978. So in Switzerland, that's to me the only known country which is recording coordinates that so much back. And today they have almost 400,000 metadata records in the catalogs all over the different libraries with the coordinates. And these 10 or 12 years back, when I show up on one of these conferences, I was playing with the idea of search system, and they in fact really love it, because they had all these data. They were recording it for such a long time, but there was practically no interface which would use it. So I ended up working on ETH Zurich, one of the most prestigious technical universities in Europe, in the Central Europe at least, and had to present the prototypes and ideas for how the geographical search could run for this amount of documents. And that's the beginning of Klokan Technologies, in fact, because they said, yes, we want to have it. Here we have some small money rest in the ground. We would like to hire you to work on this, but we can't pay you as a self-employed person from Czech Republic, so we have to create a company in Switzerland. So I made a company, and that company is Klokan Technologies, and that was in fact our first contract and first real product. It allows you to search with a map. It was also one of the first interfaces, maybe even the first one, where you don't really have to search for with text, but you are searching with a map. So panning and zooming around defines the query. You can set attributes and filters for time and different location, choose which library you want to search for or search in, and it returns you the maps. So suddenly, from a search which took usually like half an hour up to multiple days, it was across different libraries in Switzerland, you ended up with seconds on getting the information in which drawer, in which library in Switzerland a map is, basically. So you know then you should open this particular drawer, get it out, and here is the map you are looking for from that period, showing that place, or filtered by additional data. So I was lucky that they wanted this. They funded that, and then I showed that in UK to Humphrey Soudal from University of Portsmouth, and he loved that as well. So we started to work on another project, where in fact the result of the search is not a place where you find it in which library, but it's directly the high-resolution image on the web. And that was the beginning of WorldMaps Online. So that's the search engine for historical map, I believe, in this moment, probably one of the biggest, with, in this moment, over 35 partner institutions, which runs as I explained. So
welcome to Old Maps Online. As you zoom and pan anywhere on the map, welcome to Old Maps Online. As you zoom and pan anywhere on the map, you will immediately get the best records assigned to this particular place. a further narrowing of the search is possible, either on timeline, definition of scale, or full-text search. With just one click, you will arrive at the institution that provides the map to further study and explore the heritage of old cartography.
Here we are, cut. Cartography. So that's the basic idea. We send people to the websites of the individual institutions where they can explore the high-resolution maps, and it's up on the institutions what else they offer. So they receive the visitors, and in fact, for I would say 100% of the institutions, we are the source of the most visitors. The portal is optimized for Google, so if you search for old maps of and a place name, you name it, you end up usually on our website, which shows directly the list of the maps in different regions across different institutions, and people can browse, choose the maps, and by single click visit the deep link into the catalog and web system of the institutions who publish the map. If the institution offers download service, then they can download it and do what they want. If they offer map service, they can. It's simply a discovery mechanism for the old maps. Later on, we made also a mobile app, which is also pretty cool. It in fact allows you to work with similarly with the doesn't play. Yeah. So the idea is the same, but you have it on the mobile device, which knows your GPS position. So that's the main difference compared to the desktop. And you can discover the maps which are showing the place where you physically are. Swipe, choose these, and then if you tap on the magical button in the right button part, you can in fact walk on a map which is 100-year-old in the place where you are. So that's also pretty powerful concept and a toy for people who loves old maps. Now the next issue was how to make it more easier for the institutions to turn the paper maps into the digital world. That's why we started to work on the Georeferencer system, because getting from paper to screen and to GIS is a tedious process, and for most of the librarians it was hard, and it was not shareable, not in a web modern way. So we simply jumped on this service. Initially, it was an open source system which all the librarians could install in house. But after some time, we realized that for most of the map librarians and the institutions, it was in fact problem to deploy and manage the system in house. So then we turned that into an online service, which is centralized, and it runs in a web browser similarly like Google Docs or Gmail or another services. And it's a system which was originally used by British Library. David was since the beginning in, and it allows in a web browser to turn the scanned map, assigned location, and turn it into GIS-ready standards and formats. And in a collaborative way where multiple people can work on the same map, in a way that you store the information who did what and how, which is also very important with the old maps, because if you are georeferencing, you want to keep the information, how was the georeference done. If you derive later on any data and vectorize on top of the map, by wrongly georeferencing, you are introducing error, which is then not traceable back if you use the traditional like ArcGIS system, because you lose the information about how the georeference was done. In the Georeferencer, because it's collaborative and because we have all the revisions, all the versions, we know who did what and how. Anybody can have a look at the history and basically say, yes, but you have a theory where you say this river was there and that bridge was on that river here, but you made a mistake in the georeferencing of this map because they can trace it back as attestation of the place for the data. So that's one of the core like research ideas for why to make it the way we made it. And now we are coming to the point where it used to be that an institution had to talk to us and we did the installation of the system. It still is in this way, but we are adding a functionality where everybody can in fact start to use the system immediately. IIIF is a big part of that because most of the institutions are publishing their scanned documents through IIIF standard. You can in fact have an extension in a web browser, and when you are browsing over the internet and you end up on a website which shows a zoomable map in a compatible format, which IIIF is one of the compatible formats, the browser extension tells you, well, here is something important, here is something what you can use. And if you click on this icon, it will bring the map into Georeferencer as either as an image or as an scanned as a georeferenced map, and then you can start to work in the environment with other maps. The basic user interface of the georeferencer looks like that. So if you have a map which is not yet georeferenced, it's displayed on one side, and on the other side you have a modern map. And your task is to identify the ground control points, the points which are equal on the different places. We have this fancy magnifying glass, which is great also for touch devices, so you're not touching on the place which you are identifying. You can drag in very precisely, or you can drag with this icon on the resolution where you are. Whenever you type a point, in fact there were coordinates down there, so if you don't have to use a map as a reference, if you know the coordinates, you can also type it. All the coordinate systems are supported, so if you know that this is this is map made in Ordnance Survey grid in United Kingdom, you can provide this information, and then the map will be correctly georeferenced. There is a way how to clip the maps and a set of transformation, just with basic scaling, so remain north-oriented, kind of. Then basic rotation, similarity, affine transformation with skew polynomial, which preserves quite well the relations between the locations on a map, so it's more suitable for deriving the data. And TPS, which really puts the point on a place where you say it should be, and everything else in between is recalculated. So if you make a mistake in one point, you kind of like screw up the whole area of the map for georeferencing. The Georeferencer has really one thing which is really cool, and that's an overlay mode. When you are editing precisely the location, so by holding Shift, you are switching between the overlay and the map. And if you see a problem, you can just drag the point to a different place, and boom, and it recalculates in JavaScript into a different position. So this is in fact faster than in ArcGIS and all desktop applications, and it allows you to make really perfect overlay and georeferencing with the set of ground control points. As you have seen, it has a slidable transparency as well, and other options. So that's for the georeferencing. We have a basic transcribing tool as well. So if people want to record what is written on a map, we made a tool which is optimized again for tablets and touch interfaces. But we may probably also just collaborate with another tools which are out there and just interlink and bring in link data and other information which is more important than just the basic text. That would be pretty cool. Like that's a way to go really with this tool. That people can record toponyms and they can use the old maps as attestation of the name for a given time period and record this in linked data gazetteers, so the whole knowledge is preserved. And through recording, we can go to vector data and have this beautiful map in the end with time slider for the whole world. View is another tool on the top that basically turns the map into an overlay, which is reusable by all other tools. So everything what you see is in fact embeddable in a blog post. And whenever it's possible, we also expose like OGC WMTS service, so you can load it into GIS. This is a globe which runs in a web browser, and it shows the map. So in fact, going from a paper into this sort of cool visualization that you can embed in your blog posts or use in your article, it's a question of a couple of minutes, and you can try it right now. Just like go to georeferencer.com, drag and drop in JPEG, and follow the guides in the web browser, and you are done in a few minutes. Image is a IIIF viewer, basically, because whenever you upload us a JPEG, we turn it into IIIF, in fact, in Georeferencer. Another really fancy tool, which is a research tool in the end for working with multiple maps. So you have a concept of like my private maps, where you can have the local JPEG files which you georeference yourself, and then the geographical search, which you know from Old Maps Online, for different institutions or for the whole database of the maps which are out there. And if you choose a map, they are stacked on the right side. You can reorder them. So tell which one is on the top, change transparency of the individual maps, and if you see a problem with georeferencing, of course, you can click on the edit and fix it, and then it's fixed for everybody else as well. So that's like an interface to work with maps which are stacked on top of each other on the correct geographical location on a modern map. But if you have already done the selection of multiple maps, it makes also sense to use different interfaces. And we have them here on the top. One of them is Grid with synchronized location. So whichever map you move, it will show you the location on the other maps without deforming the maps. So those are still undeformed images, not warped. You are showing the archival document, but the GPS location or the location point is recalculated on the right place. So in this case, the images are not deformed. You are just showing the right place. There is also Swipe, which you may know as well. Again, these things are embeddable in a blog post or pretty easily shareable with somebody else. So if you make a selection of the maps from different sources, you can just make a permanent link. Oh, there is a hidden functionality. If you hit K. Yeah, so you can make a permanent link and send it to somebody else, and he will see exactly the set and the location of the map which you have selected. Another big part is exports. So as I said, we preserve as many standards as possible. So down here, you can get links for WMTS and tile.json and XYZ tiles. So you can in fact code your own JavaScript applications or use the maps as they are in all the traditional map interfaces. This is QGIS. So going directly from the Georeferencer system into QGIS is really just a question of copy and paste of a link which the system provides, and it means it's just open to further reuse. Here we are. The same with ArcGIS, ArcGIS Online, and all the other tools. So there are outputs. A lot of the visual stuff you have already seen. The mapping service. You can also export GeoTIFF, and we have also the metadata enrichment. So what was in the beginning on the BoundingBox for the paper maps is you in fact get all these MARC records or ISO records for cataloging out of the system as well. So if you are scanning the maps and you put them online with IIIF, then you can use Georeferencer, or you can ask other people, your online visitors, to use Georeferencer, and this will lead to enrichment of the metadata. In fact, institutions, if they jump on the system, and institutions have to pay for getting the account, then they have unlimited number of maps in the Georeferencer, but they receive also crowdsourcing support, a lot of reports about who was doing what, and this crowdsourcing is very helpful. It's also used on David website. Is anybody here who helped on David website with the Georeferencing? Yeah. Who? So that's the system which is helping to boost the engagement on top of that. And I believe we should improve that one as well, like sending letters. Thank you for your help, and really making a bit more game around that. Those are different applications. This is the David's Georeferencer. So it can be styled, embedded in a website, and adjusted. And it's really, we had quite a lot of different applications in different countries. But the system is localized. It has been used in Netherlands, Spain, in Asia, in Czech Republic. We had a huge pilot where we ended up even in the evening TV news, on the official state channel, and then we made a project which was combining of 35 institutions where the press releases were synchronized. So all these archives and libraries managed to be visible really through the system, and it was really quite exciting for the press, and reviving all these documents through this online system. Okay, institutions receive also the geographical search. So if you want to search geographically in your digitized collection, it's in fact part of the Georeferencer now. We used to have MapRank separated, now it's part of Georeferencer. So just search in your own system is quite easy. And those are the examples of the styling of and how it can look. So it's a pretty exciting project as well in Wales, in fact, for digitizing tide maps, for collecting church tags. And they had about 1,000 maps, each of them like 2 to 3 meters size, very detailed. They put them on a curved wall and used a panoramatic robot with DSLR camera. So tripod and robot which is taking photos in a grid, and a stitching software, and they were like moving on the curved wall. The maps were with some magnets, and they had to move the magnets to different places so that the panoramatic software can then remove the magnets from the map. But once they digitized it, and this was like really detailed map which were quite often visited, so most of them had to be restored before digitizing. They also put them online through the system, and nowadays all of these maps are really stitched into a seamless one layer from, is there a date? I think 1740. But I should check it on the website. So that was also a very exciting project. So we are coming to the end. I believe the vectorization is really, really cool feature, and that's where we should now go. So once the map is georeferenced, extracting the vector data choose a correct process in a collaborative way, and then bringing it into shared databases, whatever they are, or into beautiful maps for zoom in is the next big step. Georeferencer has an integrated vectorization tool, so once you georeference the map, you can click on this Open in Geo Editor, and this will give you collaborative online system, which is completely freely available, where multiple people can work like in Google Doc on top of the same map and vectorize and record fields, have a look at measurement tools. You can draw polygons, lines, points, and basically create GeoJSON, which is then stored in Google Drive in this moment. So you control who has access the same way like you control when you use spreadsheet on Google or another tools from Google. This is just a dummy recording. We turned that into
the Geo Editor mobile app allows you to add your scanned map or map processed with MapTiler, display GPS position, choose the popular background layer, and compare the result using the opacity slider. Just create your project, mark points, polygons, and lines. The application enables to collect field data related to the particular location even in offline mode. Add custom properties and attach photos.
Yeah, so it's one of the apps which has concept of foreground layer, background layer, and layer where you can draw. And it's for free for Androids, tablets, phones, and iOS. And it can be improved, adjusted for the project if you want to collect a certain set of data. Augmented reality. So over the last how long? A year. Yeah. I was amazed on one of the conferences. They put me on head the Microsoft glasses. I don't know if you have seen the device for interacting with the user interface. In fact, in Madrid. I believe this is next big shift in the computing interaction, augmented reality. The way how we enter a space, and then our space is going to be enriched with contextual information to whatever we are looking at is really the next big shift, where we forget keyboards. I mean, for certain use cases, we forget keyboards and mouses, and we will just have it in the glasses. Apple is working on that, Google is working on that, Microsoft is working on that. And now, in September, Apple, as you probably may know, announced new version of iOS, which brings this to the masses. So if you have the latest iPhone or iPad, you may install an application any applications which are doing exactly the augmented reality, but it's the first small step. And with the augmented reality on the mobile phones, you're looking through the mobile phone screen and you see something what doesn't exist on the right place, and you can interact with that. So we played with David's maps and terrain, and yeah. So this is one of the prototypes where you find a table, and then you put a map like that on top of it. So you are really holding a phone, and you can walk around that, and it's a 3D map from David's collection wrapped on a modern terrain, and you can explore it the way you want. So one of the prototypes, and then we discussed with David, well, yeah, this is nice, but what would be the first meaningful use of this technology for old maps and history? I mean, we all know that in the end, where it goes is that you end up in a place which is old, in an excavation place in Pompeii or wherever, and you will see a lot of contextual information about the history. You can slide in time and go back. So this is all something what will happen sooner or later, but it's not yet there. So what we can do now, what is really cool. And we come up with the idea of reusing David's globes. So this is an app which is launched today. If you have iPhone or iPad, you can search in App Store for AR Globe and install it. And that's recording we did just half an hour ago here. And David has here a couple of devices with the app installed. So if you want to play with that, it just puts the globe in a virtual globe in a place you can explore, zoom, and you can even sit inside of the globe. And then it turns from augmented reality into virtual reality, because through the screen you really see just the globe around you. So there are seven or eight? Seven globes. I believe you can see them also physically here in the collection, and compare the virtual globes and the physical one. Some of them are of the Earth, some of them are of the sky, so celestial. So we hope if you play with that, please take some photos and share it.
Now I need a new phone.
Yeah. That's it. Thank you a lot. Try that.
Time for some questions.
Peter, first of all, I want to say Jeff McGee from the Building Center. I started using MapTiler in like 2011 with some David's maps, and it was just amazing. And it really helped me get my head around tiles and get me started mapping APIs. I just think it's amazing that you haven't really found a niche. You've just like taken on everything. You don't, you must sleep, of course. I guess one thing I noticed is that you're using is it MapBox GL as your API for a lot of this 3D, a lot of the vector maps or something like that?
For the vector maps,
Do you
yes.
have a deal with them, or just you use their APIs for free, or is there some
It's in fact open source.
Yeah.
We are using a lot of the open source stack from MapBox, but we are also some of the people in the team. I really love the team. It's all possible thanks to the team what we do. So I'm really pleased that I work with clever people. Some of them are also committers on the OpenLayers. So in fact, there is now an OpenLayers 100% equivalent to MapBox GL zooming on top of vector tiles, and even interpretation of MapBox styles. And you don't need WebGL.
And is that in OpenLayers 3, or is there
OpenLayers 4? Yeah.
4?
Yeah, the latest version. So if you download the latest version, one of them was 4.6, I think, was released just 3 days ago, something like that. So if you download that one, you can really load like GL style from MapBox and vector tiles, and you get all this fluent zooming and map which looks practically the same way. And it's all done in JavaScript without WebGL, so you don't need hardware acceleration on a computer, which is an advantage. It's a bit slower, but runs everywhere. It's one of the cool stuff. Pleasure to help. Yeah.
Peter, I'm interested in the vector tiles that you're doing, and when I see that whole application on a small drive, I think that could be like the atlases we have on the shelf here. One of my problems with the flow of this information is, how do we preserve it? 50 years from now, how can we have the equivalent that we have with the old maps with what's happening today? So do you want to comment on that? Do you think that's realistic, that we could do some projects where we would essentially say we're going to freeze this?
Mm-hmm.
This is the way the Earth looked in 2017 with the technology that you developed in the styling that somebody did.
Yeah, I perceive.
And just hope, do you think it can persist, or are we going to have trouble reading it in 5 or 10 years because we may not have the tools to open it?
I think the answer is that what is worse of it is going to be upgraded, kind of. So if somebody really wants, the data are more important than the software, and what is worse of it is being upgraded. But I'm depressed from that as well. It's a serious problem. I will work my whole life on something, and in the end, when I die, there is probably nothing, because all these things are so moving so fast, and if you don't upgrade this stuff, it will die out. So I have a personal problem with this as well. Sometimes I think, yeah, maybe I should not be a software developer. I should build walls or whatever, dig into stone or something what is going to be preserved. But I believe if a technology is worth of it, it's going to be upgraded basically, and data are more important than the software. So if you are creating digital data, which are worth of the effort, then people after us will always use new interfaces and new software tools to show the stuff and to interact with it in a new ways.
So that's one way it could happen. You could also find the technology equivalent of the binding, which is to freeze it in a machine.
Yeah. You can
and
put it on a
the machine will
virtual.
always run as long as there's electricity.
But the problem of today development is we are all using APIs. Everything is API there, and a glue in between, and data from that server, data from this cloud, and it's impossible.
But you said it's on the stick, it can be taken out.
The OpenMapTiles software
Yeah.
is something what we can preserve for next generation if they are interested.
That's why it intrigued me. Yeah.
But it's
I
rare.
think there's an increasing need for that kind of thing.
Mm-hmm.
It would be worth doing.
It's a serious problem.
Yeah.
This is fantastic and really inspiring. I'm curious where it will all go toward a realistic virtual Earth with time slider and adding avatar bots. So could we go from even Google Hangouts to YouTube's into a 3D interactive virtual world? I think Second Life Open Simulator with a realistic Google Street View Maps Earth. We can all add it together for archival purposes. And a realistic virtual Earth, even with experimentation and even with Minecraft to go from actual virtual back and forth.
I guess you can do that right now. you just need to work on the data. The data is missing. So for a small region, if you would choose, I don't know, Rome at certain date or something, you could make this happen now, because there is nothing what would be missing on the whole stack. It's just the effort which you have to put in, and if it's meaningful, if somebody wants that, if somebody is willing to pay for that, and having people to make this happen. But it's possible now, so it's more a question if it makes sense and how. I'm personally not as keen in the virtual reality. I really believe more in the augmented one. I feel it much. The main reason for this, for me, is that you can interact with other people. We can, in the moment where the whole group see the globe here, we can talk about it, and that's what makes it much more pleasant than the virtual reality, where you can interact with other people too, but they are not physical. So if you already happen to be in the same room, we as beings love to interact with others, and this possibility to bring in something digital which doesn't exist, enrich this interaction and talks and excitement. It's like showing you something on the screen of my phone and laughing together. It's much more fun than just getting a link and looking each separate. Yeah.
Thank you very much.
Mm-hmm.
I just want to pick up on your answer to that question, which seemed like a very futuristic vision. And then you said, well, that's possible now, as long as someone pays for it. And you've talked about all these things that you made possible in a very short number of years. So I'm just wondering about the things that are impossible at the moment. What are the things that you don't know how to do that you can dream of?
That's a good question.
I'm georeferencing.
everything what is related to physical, like traveling or somewhere fast or these sort of things. But in the digital world, I don't know. I would have to think about. Maybe I return to this later on and tell you.
Well, preservation is impossible, you said.
Yeah, the digital preservation is one of the things which is practically impossible in digital. Yeah. But something, if I come, I guess you are more targeting something really, really cool, right? So having an idea for an amazing project which would really rock the world, but it's not possible now. That's what you want to hear, and I do. Yeah.
Here's a suggestion for that. You were showing a map that changes, and you could dial in what year or span of years, but you're using the modern elevation data.
Yep.
It would be nice to be able to get the historic elevation.
In fact, the elevation data are not old, but there were the water. So the shape coastline, for example, they are different. So we have them. What's the name of the project? Yeah, they did this. Choose the research and again attestation of where was the coast, proved in different materials. They are recording GIS data for rivers and shapes of the rivers and for coast. And that's part of the process. So if you zoom in Turkey or close to Greece, you can find quite a lot of spots which are now elevated over the sea than they used to be in the Roman times. So there is a difference already on that one.
So is anyone doing that in the United States, like Mississippi River?
I'm just a dummy guy. I don't understand these things.
Actually, Eric Sanderson is doing it in New York City.
Yeah.
He's done historical elevations of Manhattan for Manhattan, Peter.
Yeah.
Project.
Okay.
Yeah. They use old maps to get the old elevations.
I play with the technology. The data are for researchers, and I love it. I love this combination. But it would be exciting collaborative project as well.
I mean, I mentioned this to Petr the other day, and within a couple of hours he'd done it. Well, maybe not even in a couple of hours. He'd already brought in this other information from this other source too.
Yeah, because they made it available as open data. It's on GitHub in GeoJSON, and there was API which we could integrate, so it was really a question of.
I just had a kind of very prosaic question. All my fun questions have been taken already. So the prosaic question is, it's clear that you're such a passionate guy about this, and that's, I think we're all feeling the passion, getting passionate about this. On the other hand, it's a commercial company. What's the balance that you strike between making money and providing knowledge for people, particularly in academia and general public?
That's a good question too. I have a company not because I want to make money. I have a company because I want to make more important things, and I'm not able to do that alone, and I need a team. That's the reason why I have a company. I don't have any investors, so I don't have to prove that I'm profitable. Nobody is pushing me to generate a huge amount of money to have it on the bank account or something. So I can do what I want as long as we have enough for the team. If people are happy to working for me, and they are happy also because we work on different things. It's quite exciting to work not all the time on the same project, not all the time on exactly the same task and being in a huge corporation or something. We are a small team, effectively play, and in the same moment deliver. The business world is loving this as well, kind of. So we do consulting, and because of the expertise in the field, people are willing to pay us good enough for being able to work on, 50% on really stuff which earns money, and another 50% on research or on on things which is just playful. And if you have open eyes and see the opportunities, then you are usually able to turn the research into something what you sell later on. So, and I believe there is also a huge potential sometimes. Like sometimes you may reach, you do like MapTiler. I mean, it's a software which was done for old maps. Nowadays, it's processing stream of satellite fleet for a big company on a cloud. I mean, it was a lot of development, but it's still the same software which was done for old maps, and it's application from culture heritage into various different fields, and that's exactly that. But we have to be careful to not break too much for free.
Going back to the question about what's something's impossible, and firstly commenting on what you were saying about the Mississippi River. Studies of ancient there's a huge amount of scholarship on studies of ancient geomorphology. It's a very complex task. There are, for example, there's a paper in Nature recently which I've transcripts attached to it that could allow us to look for paleochannels from Landsat imagery to be able to evaluate this. Whether when those are then ground truth, there's often a discrepancy between the data from the script and the actual field. So it's a very difficult issue to deal with. I've got another question for you based on your extrusion data. Now, you said in your talk that you had to provide height data in order to extrude the three-dimensional building. What do you think the potential is for actually looking at the imagery from satellite data and using some sort of feedback loop to determine the height data from the way the satellite imagery looks, and then the second step would be to understand the nature of the shape of the building, the type of building from the satellite pixels.
This is done. Google Maps is showing you this. If you see the 3D buildings in the center of the town on Google Maps, like click on satellite Google Maps and build the camera, and you will see it's a shape which is not made by humans. It's shape made by not satellite imagery, but flights with the airplanes under an angle. So if you take enough of the photos, like at least 5 of the same place under different angles, 45 degrees. In fact, they fly with the airplanes and they are taking one photo down, 1, 2, 3, 4 on the sides. And with these photos to the sides, you can then reconstruct the shape pretty well.
For sure. What I was saying, I mean, you still then need to fly the airplanes to do that at a different angle. What I was suggesting is that only using the satellite imagery from above and a comparison with the training data set, would you think it would be possible to actually estimate the height and the variety?
People are doing that with LiDAR. So if you already fly, you have a laser beam or a signal which reflects at different.
Again, that's
but I have seen a project doing this on top of old videos, which was pretty exciting. So they had old videos from 1960 or like first half of 20th second half of 20th century, and they were doing the photogrammetry reconstructions of the shapes based on these videos, because you have enough frames, and if people walk, and if there is enough videos of the street, you can really reconstruct the 3D model out of the videos. So make buildings and record everything around it. That's pretty exciting application in this field in the digital history or in digital humanities. if you fly now, there are ways how to get the 3D now, but
The implication of what I'm saying as well is that you can take an old map, say like an old map of London, and looking at the way that the building is pictured on the map, you can get looking at the probability for what that building will do.
the map contains some sort of information for that, or
Sorry, but I just want to point out one other thing. I'm going a little far afield from this gentleman's question, but just I think what's so interesting about Peter's economic model, which Nick sort of hinted at, it's important for the academy to think about is this combination of commercial and then the research work. And in the 10 years or more that I've worked with Peter, it's been one of the wonderful parts of my experience with him is that I'm funding projects, and then I know that out of these projects will come both some commercial work to keep Peter alive, which is really important, and his team, but also shared with the National Library of Scotland or the British Museum to help their projects. So it's something to really think about what you've heard today from Peter about how his company actually functions. It's not alien to the academy. I mean, there are research centers at Stanford that are teams that do commercial work and research work. Yes, Nick? I mean, yeah. But I just think it's a very, particularly in this area of cartography and computational power and GIS, it's a really potent way to go about the problem. So I commend you for having done well and continuing to do well.
Well, and you know, David, I think that in parallel to that, you think about firms like Stamen, of course, that are doing open source contributions at the same time that they're doing either grant funded or private funded things. And one thing Eric Rodenbeck told me that I never thought of was that one of the reasons they open source a lot of their work is if they didn't, it would belong to their client.
Yeah.
They could never touch it.
Yeah.
is the open sourcing that's also interesting. Like the whole OpenMapTiles project. It's an amazing work. I could have bought a house probably for the money I put into this, and it's all open source, 100% open source project. And I have an experience from early on that if I do this, the money will come. I don't know how in the moment when I do this, but I will get that back, and it's now starting to happen. In fact, so it's always tough decision if to go open source or not. Sometimes it's important to keep something what you can resell, but yeah, open source is great. Everybody loves to use it. So yeah, and Stamen is one of the companies which contribute a lot. The maps, some of the maps we have seen are from like ported version of the Stamen, and yeah, MapBox too is great stuff. Open source. So the Roman map would not be possible without MapBox open sourcing their components.
You mentioned the advantages of linked data and being able to identify, transcribe and identify places. And whilst with this progress in doing individual stuff through human intervention, as we move into the kind of the modern period, we're just dealing with hundreds of thousands of maps, and it seems that's the kind of thing that only with at least semi-automated and automated processes, we're going to make a lot of headway with that. Have you got any sense about where that's at and what's the current state of play for automated transcription and data?
It's moving forward. There are projects which technically it's doable if you have a map series. If you have a map series, you can train the software and you can do something what is very practical. And people did it in Switzerland. They did, analysis of forestation across. Switzerland is one of the countries which has. It's amazing for 200 years maps which looks exactly the same. Because there was no change in the politics, they still have the same over the 850 years of the country, the same like owners of the property, Very often it's like moved from family to family, and the cartography is absolutely like in one line. Nothing like that in Czech Republic or other, rarely in other countries. You know, in UK, the Ordnance Survey is also like set of maps which has clear follow-ups, but in Switzerland it's very clear, and therefore you can train the machines to recognize the places, to recognize the icons, and you may feed it with the different editions of the maps, and it's then doable automatically. But having a system which would do that completely automatically for any map we have in OpenMaps Online, that's one of the projects which is science fiction in this moment, and it's very challenging, and it will be damn cool, amazing. So this answer, we're coming to the answer.
So I work for the National Park Service and on a project that involves tracking the spread of fungus in the white pine blister rust in Synchronized Location National Park. And one of the things when you go to most national parks is they have some kind of tabletop thing that looks a little bit like your AR globe or AR table at the end. And I'm always looking for ways to try and share what we're doing as researchers in the national park with visitors. And it seems like that would be a very cool way to basically overlay our data and data from other projects, like science going on throughout the parks, onto some kind of park maps, and people can then start interacting with this thing and projections into the future, maybe if there's old maps here or other places that can get digitized and really kind of play with that. So yeah, I was actually talking to Jeremy Balance's VR lab and looking into like taking cameras out to our sites. But this seems like it could be like almost as good with. It sounds like we could practically do it with what we have with your tools. I don't know if I'm wrong about that, or if you have any suggestions.
Yeah, so what is the practical problem you want to?
So basically, we have a lot of data that nobody looks at, other than people who read the papers that we publish, and that's very few people. There's tons of visitors that come to the park. They don't have any way to like visualize what we're talking about, and so to have to basically create a topo map of Sequoia Kings Canyon, very similar to what's already in the visitor center, but to have like an AR kind of version so that people could then like click on different projects that they might be interested in, like blister rust or wetlands inventory of birds. Like they can just like select those things and put them on. Like it sounds like basically all we would have to do is feed data into what you already have set up, right?
Do a bit of coding.
Yeah.
But this AR movement, but that was one of the ideas we had with David as well for the AR app. You have a map like this one on the wall that you can in fact turn the physical object into something that you can zoom or pan. So you will look through. I mean, later on you will have the glasses, but now you can have the iPad. Just have a look at that one, and in fact make this, and it would zoom on the wall or on a flat desk. So that would be like having a look at the modern topo map, but then bringing completely different data while you are interacting with the physical object. If you recognize where it is, you can enrich it with something else that goes in that direction.
I saw an AR app the other day on Entertainment Weekly magazine where you put your phone up to the front of the cover and it was a movie, and it started the person on the cover of the magazine was talking to you through your phone.
So Harry Potter.
So that sort of thing is, it was kind of creepy, but interesting.
Cool.
This is fascinating talk. Thank you so very much.
Thank you so much.
Thank you.